Hello all and welcome to my YouTube channel. So today in this particular video we're going to be discussing about this particular NLP augmentation library, which is NLPAug. So this particular library is majorly focused on the augmentation of text and signal processing. So if you go through this particular GitHub repository of NLPAug, you can find various kind of examples illustrated for even text augmentation and for the signal augmentation. So there are various kind of formulations done in terms of textual augmentation and signal augmentation. So you can see in textual augmentation we have character wise augmentation, word wise augmentation, and sentence wise augmentation. And when we consider about the signal processing, so we have audio augmentation and spectrogram augmentation. So we'll cover this signal augmentation and spectral augmentation in our later tutorials. But for today's agenda, we'll taking up the textual augmentations and we'll cover all these character-wise and word-wise and sentence-wise augmentation. So in this character-wise and word-wise and sentence-wise augmentation, we have various kind of augmentation process with respect to each and every type of augmentation. So if you see if it's a character level augmentation, then we have keyboard augmentation, OCR augmentation, and random aug. And similarly, when we consider about the word augmentation, so it's have antinomy augmentation, contextual word embedding augmentation. Such kind of different subdivisions of augmentations are there in various augmentation steps. So this is how it is generally proposed, and even these all kind of augmentation involves word to vec, GPT to BERT type of model, so that augmentation becomes more efficient and more trustable. So it's not like it will be just a random word augmentation, it will be more of contextual kind of things. So even we're going to be working with random augmentations also over here, but you can use it or you can not use it. It depends upon your use case scenario. So let's just walk through the code and let's see what other things are required and how we can install this particular library. So this is the code, or this is a notebook where I'm going to be demonstrating the different types of augmentations you can proceed with. So these are the preliminary steps you need to install, and once the installation is done, you have to download few of the files as well, like word2vec and glove and fasttext. So these are the pre-trained models you need to download it for your particular augmentation, for a good augmentation. And once this is done, you have to set an environment over here in collab. And then once this is done, once this all the setuping of your environment is done, then we have to import NAC, that is character level augmentation and word level augmentation from particular NLP library. And this particular is sentence level augmentation. So we'll be importing all these three types of augmentations, and we'll be seeing each one of them one by one. So this is the one of the import we need to do for the flow creation, and this is one of the utils we need to perform when we do it customly. So for this particular tutorial, we are taking the example demonstrated in particular GitHub repository only. So they have given that this is a text, and we're doing the different augmentation on this particular text only. So this is a text we're working with. So this is the original text. The quick brown fox jumps over the lazy dog. So this is a text, and we'll be applying the number of or different number of augmentation over it. So let us proceed. So first augmentation is a character type augmentation. So in this character type augmentation, we have OCR augmenter, which generally performs something like OCR model does or OCR tool does. So if you have used any kind of OCR tool like Tesseract, so they must be not good in some of the identification of the particular character. Like if it identifies 0 as 8 or 8 as 0, so that kind of error can be produced over here also. So this particular augmentation generally takes insertance and use OCR augmentation function to produce similar kind of errors. Like how does the OCR produce it? So this is how you do it. You have NAC that you have imported over here, and once that NAC is introduced, you can use the method of OCR augmentation, and you can store in aug. And once that is done, you can use aug.augment. You can pass your text in it, and you can give the three, that is the number of text you want to generate after this. So it will generate three kind of sentence once the augmentation is done. So this is how you're going to be doing it. So only these two steps are required for proceeding with the augmentation, and rest is just a print statement for particular outputs. So once you run this particular cell, you're now going to getting the original text as like this: the quick brown fox jumps over the lazy dog. And similarly, the augmented text. So we have, because we have given three numbers, so it will generate a three type of text with OCR augmentation. So if you see, it is the quick brown. So brown R has been replaced with K, and jumps over R is replaced with K. And similarly, if you see other sentence also, it works for that particular sentence. So it has replaced different kind of character using the OCR augmentation. So this is how even OCR does, right? So it replaces, sometime OCR O replaces with 0. So you can see O has been replaced with 0. And sometime if you see Z has been replaced with 2. So you can see LA2Y. So this is even how OCR identifies the particular character in real time. And same type of things has been done over here as well using the OCR augmentation. And next thing is keyboard augmenter, which is generally a form of character augmentation. So what it does is, you take a text, you pass it into this particular keyboard augmentation, and it will just replace that particular word or random character inside this particular sentence with the nearest word in your keyboard. So if you see that this particular the quick brown fox has been replaced with gox. So F has been replaced with G. So if you look into the keyboard, the nearest word, the nearest character uh, beside the F is G in your keyboard. So it has replaced with that. So similarly, it has done it for jumps. So M is J is near to M, so it has replaced M with J. And similarly for other characters. So this is what a keyboard augmentation is doing. And if you go to the random augmentator, so it generally takes any random words and just do the augmentation. That means it replaces with any kind of character. So there is no such thing like keyboard augmentator or OCR augmentator. It just randomly replaces with any character in the history of the keyboard word. So this is what it does. So if you see, you have provided the action insert. So what it does is, it takes the sentence, and it replaces the different kind of letters inside this particular sentence with a particular word and insert it. It doesn't replace it, it inserts it with that. So brown has been written as @brown, so it has inserted extra character with brown. And similarly, we have this substitute character randomly. So here it has added one more character, but here we are substituting with a particular character. So you can see we have provided actions will substitute. So now if you see, brown has been replaced with BROWN. So N is has been replaced with 0. So this is what it has been done. So it has substituted with the particular character or random character. And similarly, we have swap action also over here in random character augmentation. So what it does is, it generally swap the particular character with different or random character in the history or in the dictionary. So if you see, fox has been replaced, or if it has been swapped with ox. And similarly for other characters in the particular sentence. Here the one more action is required, like delete. So it generally deletes a random character in a particular sentence. So this is all about this particular character augmentation. And now we'll go with the word augmentation. So in word augmentation, there are various kind of models we're going to be using, like word to vec, BERT, fast tag, globe. So all such kind of models can be used to augment a particular word. Till now we were doing the character level augmentation. Now you can perform the word level augmentation. So for that, what it does is, it's a pre-trained model. It's going to be using the pre-trained models, and it's going to replacing a particular word with particular nearest word or or different kind of things it can be doing. So let's walk through it. So first we have a spelling augmentator. So what it does is it substitutes the word by spelling mistakes word dictionary. So it replaces with the spelling mistakes. So if you see, this is the original sentence, and once you run this spelling augmentation and give the three, that is number of three sentences you want generating once you give the sentence. So this sentence will replace with particular spelling mistakes. So if you see the quick brown, the has been replaced with THA, quick has been replaced with QCHICK. So this is how it is doing. So it has substituted with the spelling mistakes. Similarly, if you see, this is the different sentence and it has generated different thing for similar spelling augmentation. So now the next thing is we are going to use word embeddings, which is word embeddings augmentator, where we're going to be using a word to vec model here, and you can even also provide globe or fast text. So this is what word embedding does, and that means it takes a particular word embeddings of particular word to vec or globe. So here we are taking a word to vec. You can specify globe or fast track, and we are downloading its model over here, and we are saying that insert a nearest word or randomly word by any word embedding which is similar to it. So if you see, this is the original sentence, and the quick brown for fox jumps over the lazy dog. So if you see, Alzira over the lazy superintendent dogs. So this is what the model is doing. It has taken a randomly similar kind of words which it has been trained, and it has inserted over in the sentence, in the original sentence. So maybe it has identified that in a particular dictionary which it has been trained. So it has taken all those words and matched with it with the similarities, and they found that okay, Alzira and Superintendent dogs are kind of different breeds of fox and dog. So in which it has trained. So it has added that particular words in it. And similarly, you can provide the action of substitute also. In this particular we had insertion. Now we'll substitute it with the similar kind of word. So if you see, this is the original sentence, and the quick has been replaced with the easy word. So quick and easy are the similar kind of words, it has substituted with that. Or if you have provided a insert action, so it would have inserted with the quick also. So this is the particular word to vec similarity which is being taken by the word to vec augmentation. And now next is it uses a TF-ID of augmentator. So it's a similar kind of things. Instead of just using google google based word to vec, it has used TF-ID of similarity model, and it is using this particular model. And you can provide your own pre-trained models also. You can even train yourself model, and you can start providing it over here. You should provide the model directory over here, and you can start using that particular model, your trained model, and you can do the augmentation with respect to that. So you can see it has replaced, or it has inserted similar kind of words. It's working similar to the previous ones. And we have substitute word, which is TF-ID of similarity. So it's gonna substitute the particular word with particular similar word in the particular sentence. So here comes the better version of word to vec, or that is word augmentator, which is we are going to use Bert, Distilbert, Roberta, XNet. So these are state of art models, and we are going to use that particular efficiency of those state of art models over here also for generating a contextual word embeddings. So this is a similar kind of augmentation, but we just be using the Bert. So we are taking NAW, that is word augmentation, and from there we use contextual word embeddings augmentation method. So what does it? It takes the word path and it inserts a particular simple or similar kind of a word into the particular sentence. But this time it will be using the word, not particular word to vec model. So now this time it would be very good augmentation which we were doing. So let us walk through it. So if you see, the quick brown fox jumps over the lazy dog. If you see, it has learned the particular embeddings, and it has said that okay, even the quick brown fox usually jumps over the lazy dog. So it has added or it has inserted even in this particular sentence by using this word base and case model. And you have provided insert action, so it is inserting this particular word inside this particular sentence. Similarly, if you see, we have provided the substitute action, so now it will substitute a particular word. So if you see, the quick brown fox jumps over the lazy dog. So this little word has been added, uh, and it has replaced the quick brown. So if you see, little quick brown fox jumps over the lazy dog. So this is what it has added, and it has augmented. It has done with the contextual word embedding. That means it has taken the context of this particular word, and it has changed that particular context of its word or sentence, and it has matched with the particular context, and it has added the particular word. So this is what it has done. Similarly, you can use Distilbird and you can get the same kind of augmentations. It's the same thing. You can use Roberta substitute, and then we can have a sentence augmentation as well. So till now we had character-wise, word-wise augmentations. Now we can do even sentence-wise augmentation. So here we're gonna be using GPT-2 model. So in this sentence-wise augmentation, we generally use decoder transformer decoders model, which are generally being trained. So GPT-2, GPT-3, XLNet are kind of transformer decoder models because they generally built on transformer decoder model. So they generally generate a particular given sentence. So if you give a particular sentence, they will try to generate more sentence out of it. So this is the basis of the decoder model, and this is what GPT-2 and XLNet does. So here also, if we use XLNet or GPT-2, it's very obvious that it's going to be generating a sentence. Like if you give a random sentence, it will try to generate an article. So this is what it's going to be doing. And so, but this time the augmentation will be more. So let's see how does this work. So if you see, I have taken NAS, the which is a sentence augmentation I have just imported above, and I am using the method called contextual word embedding for sentence augmentation and passing the SLNet model path, and it's get downloaded into this particular aug, and we are giving the augment method over the text, and we are saying that generate three sentence. So if you give this particular original sentence, so it will generate few sentence like three sentences out of it, because it's a decoder model, so it will try to generate more sentence with little augmentation. So if you see, the quick brown fox jumps over the lazy dogs, a terrible messy split second present itself to the herd, which is we lose our herd. So this is the additional sentence has been added to this particular sentence. So this is an augmentation sentence wise. So this is whole of a one sentence. Now we have given the three sentence to pass it, so it has generated two more sentences. So if you see, this is the same sentence, and these are the generated sentence cast from the herd. The above flash is inside to the herd, and similarly, this is the third sentence it has generated. So three types of augmentation it has done. You can provide even one, number one. Also, you have to select it which type of augmentation is working for your case scenario. And similarly, you can generate it with using GPT-2. The codes are very similar, and you can just take this particular sentence, and now this time I have given a default n is equal to 1, so it will generate only one sentence. So if you see, it has taken this particular sentence and it has added one more sentence to it. So this is what we call sentence wise augmentation. And there's similar kind of things. So distilled GPT-2, you can use GPT-2 again. So the similar kind of things are being done over here. Even you can generate an abstractive summarizer augmentator. So you use the same sentence augmentator, and inside that you have abstract summary augmentation. So this time you're using a T5 based model, which is one of the best model available for even for all kind of tasks. So you can use T5 model for like question answer generation, for text classification, for translation, for summary extraction. So T5 model does all of this with a single model. So you can use this particular T5 model for n number of classes or n number of tasks. So for this time, we are using it for augmentation, and we have provided the number of beam is equal to 3. So it will look previous three words, and it will try to generate the new kind of sentence, that is augmented sentence. So if you provide this particular sentence or this particular article, so it will just generate or augment a, a summary of an a summary of an augmentation. So it will take this particular sentence, and it will generate a summary and with the augmentation in it. So this is what it has generated. It's quite long, but obviously you can go through it and understand it. So it has generated a summary of this particular, and added some few augmentation over it. And this is what a sentence voice augmentation is. So in this particular tutorial, we have discussed three type of things. One is character wise augmentation, word wise augmentation, and sentence wise augmentation. So I hope you enjoyed this video. If you like the content, please do subscribe the channel and keep supporting the channel. Thank you.